All right, Algebra 1, what's going on? The first part of your assignment this week is actually a review of last week's stuff, because, I want to keep hitting on it because it is new material. On the paper that I uploaded, on the document I uploaded for the website, I actually forgot one of the rules. Rule number 3. Okay, so hopefully you're watching this video and remember the old rule there. But let's go over these rules real quick from last week. Remember, the first rule is if you have an exponent outside of parentheses, you can distribute it in and multiply them together. So a real quick fake example. If I had x to the 4th power all to the 3rd power, I'd multiply the 4 and the 3 and I'd get x to the 12th. The other rule is if I have two things inside the parentheses, the rule works as long as they're not separated by addition or subtraction. So again, let's make up a false or fake one here. So I can again distribute this 3 into both parentheses, and that's x to the 6th, y to the 12th. Multiply the exponents together. Now, it changes when you're multiplying variables together. So I'm multiplying an x and an x, a y and a y, a z and a z, an apple and an apple, it doesn't matter. When I multiply variables together, I add their exponents. So if I had x to the 4th times x to the 2nd, I add those two together and I get x to the 6th. Okay, so when you're multiplying variables, you add their exponents. And then when I'm dividing, let's use like 8 and 3. When I'm dividing variables, I subtract their exponents. So here, 8 minus 3 gets me x to the 5th. Those are the rules we went over last week. So let's do a few examples that are kind of like the ones you did last week and are going to do this week. This first one, I need to get this 2 inside to everything. Again, like I hit on last week, you were not doing 4 times 2. If something doesn't have a power, its power is technically 1. So this is actually 4 to the 2nd power. Okay? And then I multiply these variables as well. So 2 times 2 is x to the 4th. 4 times 2 is y to the 8th. Okay? So it's 4 to the 2nd, x to the 4th, y to the 8th, and then 4 to the 2nd is actually just 16. So go ahead and write that. Four squared means whenever it's 4 squared, that means 4 times 4, right? So 4 squared is 16. Let's do another one. I got a couple questions about these ones last week. If two things are in parentheses, that means you're multiplying them, right? So when we're multiplying, we add our exponents. So I have an x squared and an x to the 3rd. That's x to the 5th. I have y to the 1st and y to the 2nd. So 2 plus 1 is 3. And then we do our numbers. Remember last week I told you to treat numbers normal. If I have a 5 and a 2 and I'm multiplying, then go ahead and multiply them. 5 times 2 is 10. So that's our final answer. Okay. Another example. This one, a little bit different than the last one because there's an exponent right here. So I got to take care of that first. Okay, just like you would in PEMDAS. I got to get this guy in here. So I have 3 to the 2nd power. That's not 3 times 2, right? I have a power of 1, and I have this 2 right here, so that's 3 squared. And now x to the 2 times 2 is 4. Y to the 4 times 2, well, that gets me an 8. This guy doesn't change, right? So I'm just going to write him again. Technically, you don't need the parentheses on that first one. You don't really need the parentheses on either one of them. But I put them. Okay, because again, that means we're multiplying. And if two things are just sitting next to each other, if it was like this, that also means multiply them together. When things are sitting next to each other, they're multiplying. When things are in parentheses, that also means they're multiplying as long as there's nothing else in between them. So let's just keep the parentheses. Why not? Still means we're multiplying. Now, this 3 squared right here is technically 9, right? So can we fix that? So again, treat numbers normal. 9 and 4 make a 36. And now I'm going to add my exponents for my x's and y's. So if I have x to the 4th and x to the 2nd, 4 plus 2 is 6. If I have y to the 8th and y to the 1st, that's y to the 9th. Okay, so just like we did PEMDAS, you got to make sure that if there's exponents outside of the parentheses, we got to take care of them first. And then if it's just this, okay, if there's things in parentheses, that means you're multiplying them together, which means you're actually adding the exponents. And then we did division. Remember, when you're dividing, again, treat numbers normal. 10 divided by 30 is 1/3. X to the 8th over x to the 3rd, well, that's x to the 5th. Y to the 5th over y to the 2nd, that's y to the 3rd. So this is a good answer. Remember, I told you this last week, if you have a fraction and then it's kind of right next to two things that are not fractions, you can rewrite it with those terms that aren't part of the fraction. You can rewrite it in the top of the fraction like that. Okay? But these answers are both acceptable, but I'm cool with that one, right? Okay, I just want to make sure we understand that when we divide, we actually subtract exponents. But we actually divide the numbers because we treat them normal. 10 divided by 30 is 1/3. Okay, so that's our review of last week a little bit. Again, the first assignment of this week is the same thing. And then the second assignment is our negative exponent rule. And here is the negative exponent rule. We don't like negative exponents in math, so we fix them. So to fix a negative exponent, you are just going to make it positive and put it in the denominator. All right. So in this example of the rule right here, this first one, the general rule, when I put it in the denominator, something still has to stay in the numerator, right? You can't have a denominator without a numerator. So if I make that exponent positive and stick it in the denominator, I got to leave something in the top of that fraction. So remember, in math, if it's not there, it's always there. There's always a 1, right? So that 1 is going to stay up top. And then we take our exponent and our variable and put it in the bottom, make it positive. That's how we fix negative exponents. So let's do this one real quick. Again, remember, it may not be there, but you know it's technically there. There's a 1 in front of that x. So I'm going to take this x to the negative 4th, make it positive, and stick it in the bottom of a fraction. And the 1 that's there stays in the top. On this one, we actually have a number there. It's a 4. So when I take that x squared, that x to the negative 2, and put it in the bottom, and I make it positive, so it becomes x squared, that 4 has got to stay up top. He did not have a negative exponent. He's still chilling in the top of the numerator of the fraction. The only thing that goes to the bottom is the term or the expression that actually has a negative exponent. So that x to the negative 2 goes to the bottom, becomes x squared. This one, again, a few more things in the problem. Same idea, though. That's 6. He's got to stay up top. He doesn't have a negative exponent. This y to the 4th, he's got to stay up top, too. The only thing that goes to the bottom is something that has a negative exponent, but you make it positive when you take it down there. So that would be the simplified correct answer for that expression, fixing that negative exponent. But if it doesn't have a negative exponent, it's got to stay up top. And then we can do some problems like the ones before, including these exponents. Now, you're not going to be moving anything until it's the last step of the problem. So I'm going to treat this problem like before. Again, if I have two things in parentheses, that means I'm multiplying them. Okay, unless said otherwise, but you wouldn't do that in this section. We just have two parentheses with some stuff inside. Let's put them together. Again, treat numbers normal. 3 times 5 is 15. I add exponents when I multiply. So x to the second and x to the negative 6. Well, 2 plus a negative 6 is a negative 4. And then the y's. 4 plus a negative 2 is a positive 2. And then it looks like we're done, but we have an issue. We have a negative exponent in our answer. Can't have that. The 15 stays, the y squared stays, but the x to the negative 4th goes to the bottom and becomes positive. Okay, so you're still doing the same rules that you were doing before. You're multiplying, you actually add the exponents, but you actually multiply any just numbers, any leading coefficient numbers, any normal numbers. But in the end, if you have a negative exponent, you got to fix it. I can't have x to the negative 4th. No bueno. We know how to fix that, though. I take him and I put him in the denominator and make him positive. But this and this stay up top, because they're positive exponents. A couple more examples here. This is another good one because it talks about division again. When you divide, you actually divide any numbers, any leading coefficients, any constants. So 3 over 15 is the same as 1/5. X to the 8th over x to the 5th. Again, I subtract, so I get x to the 3rd. And then I have 4, y to the 4th over y to the 7th. Well, 4 minus 7 is a negative 3. So here's where it's kind of interesting. Right now, we have a negative exponent. I got to fix him. This guy cannot stay the way he is. But this answer already has a denominator. These are the ones that kind of mess with kids. I already have a denominator in this problem. I have a 5. This 5 is in the denominator, right? It's already a fraction, 1/5. So to fix this problem, the x to the 3rd is going to stay in the numerator with the 1, but I'm not going to put the 1. You can if you want, but that's weird. You'll never see that answer in on a test. And what's in the bottom is this 5. This 5. And this y to the 3rd, because we fixed it. It was a negative 3rd before, but when I fix it, I put it in the denominator, so he goes down here with this 5, and he becomes positive. And that's our final answer right there. So one more like this. Again, numbers in front, I'm going to divide them. 16 over 4 is 4. When I subtract 3 minus 5 for my x's here, I get x to the negative 2. When I subtract the powers for my y's, I get y to the 4th. Now this one's a little bit different than the one before. There is no denominator right now, right? 4 is just 4. So that 4 is going to stay up top. And this y to the 4th is going to stay up top because they're both positive powers. But x to the negative 2 is going to go to the bottom. And I make him positive when I put him down there to fix it. Okay, so that's our negative exponent rule, the new rule for this week. Anytime you have a negative exponent, you fix him by putting him in the denominator and making him positive. Okay, so this x to the negative n equals 1 over x to the n. That's our rule. Okay, we got a couple of simple examples as well. If it's a negative exponent, you take it, make it positive, and put it in the bottom of the fraction. Anything that doesn't have a negative exponent's got to stay upstairs. And if there's nothing else in the problem, well, there was technically a 1 in the problem, so that's what stays upstairs. Okay, so if you guys have any questions or anything, make sure to shoot me a message on Remind or email me or whatever. If you have my number, text me. Make sure you're turning in your stuff, staying up on top of everything. This is a good time to make your grades better. I hope you guys are staying safe, having fun. Got a couple weeks left and we're done. Okay, so hope to see you guys soon.